Hello guys, welcome back to Talks Writers and another episode of Applied Numerical Computing series. In this video we want to have a look at Matplotlib, a very famous, powerful and nice library in Python for plotting graphics. So let's go for it. Okay, so Matplotlib, this is actually the fifth notebook for 2D and 3D plotting in Python. Yeah, as I said, this is quite famous. Everyone have probably heard about it. But it provides, a mixture of features that you can find in spreadsheet programs, for plotting, and also in MATLAB. So to me, it provides more features than the graphics that in MATLAB, but yeah, that's a personal preference. But you will see through this this notebook that it's quite rich. The API is quite rich. But as this notebook started with, you can see that it says that it's very similar to MATLAB. So generally, there are some minor things that you need to change, like function names. And then your code for graphics will work almost the same in Python. So yeah, let's go for the simplest example possible. So a linspace, NP, and this is the way that people usually use NumPy. So import NumPy as NP, and then importing Matplotlib pyplot as PLT. So this is indeed the object inside Matplotlib. We import it as pyplot as PLT. So for plotting the x squared in this domain, in this range, and then with red color, and then the title, and x and y as the legends, as the axis title. So you can see that this is the simplest form of plotting in Matplotlib. And then you can easily add more subplots and then change the style. So green with dash, and then with asterisk as the points, and this kind of customization similar to MATLAB, as I said. But at the same time, it says object-oriented API, and it means that you can easily embed objects in each other. And then it works like this, that you can see that, yeah, you say that fig1 add axis, and this is axis 1, and then you, for example, in this case, you work with this axis. So you create the axis, the plot object, and then you work based on that, and then Matplotlib will take care of the result. Even they are, they have some sort of collide, or they have overlap on each other. You can see one example here that add access to different axes, and then you modify them separately, and then you can easily plot them in one Matplotlib window. But a better approach for this, I'm not sure if someone would be interested in something like this. I can't see any application, a specific application science for such a graph. But the more common way is these subplots, that you create different subplots. In this case, you define the columns and rows, and then this axis is a sort of collection, and you can go through it, iterate through it, and then define your own plots, your own graphs for each subplot. And as you can see, there is a function, a very important function, tight layout. You should always call it, to make it, sort of, as the name implies, to make it visually better. And for the aspect ratio and DPI, this is quite important when you want to save figures for publications or for presentations. You should define a fixed size and a DPI, which implies dot per inch, and a sort of resolution. And then you can save the figure and defining the DPI when you want to save it, or defining DPI when you define the object, the plot object. For legend labels and titles, this is quite trivial. You can use this, as I told you, very similar to MATLAB. Set X label, Y label, and title. And for the legends, if you have different graphs, you should definitely use legends to identify, to distinguish them. And you can see this is actually the way that Matplotlib handles legends, and then the location for the legend, where to put a legend. There are different locations. As you can see, these are the corresponding location, the description of the location. For example, log 2 is the upper left, and you can see that it comes here. This is where the legend location 2. And for formatting the text of the titles, for the labels, for everything, you can use LaTeX also, and you can change the font size. So you can see that LaTeX command is converted into the X label, and then this is actually used for the legend, for the series title, let's say. So this is actually the way that LaTeX works, with this dollar signs, similar to LaTeX programs, LaTeX scripts. You can see that, you can define LaTeX inside Matplotlib as well. And also for changing the some configurations, including the font size, you can use RC programs and then update, and then sort of dictionary. You know this compound type, a dictionary to change configurations, and in this case the font size. And setting colors and also line types. You saw that in previous examples, green, blue, different types, and also you can define different widths of the like here you can define the widths of the line. So line width, line style, and a marker and a color you can use with full names here. And you can see that these are different styles actually for different in a very simple script using this x plus something, a fixed number for the y value, and then you will have this graph. So make sure to reproduce this, and then you can see the beauty of Matplotlib, and it's easy to use APIs. And for the plot range, you can easily set X, Y limit. Sometimes you need to make it a narrower bound in a narrower windows, let's say. And these are actually the functions that can use to limit the bounds, the ranges. And for logarithmic scale, sometimes you want to use logarithmic scale, so you can set the Y scale as logarithmic, and then it becomes like this. And for the ticks, these labels, these small ticks, this is X ticks and Y ticks, and you can also change the labels like this. It's a custom labels. It's also possible, to work at this. Look at this notebook as a sort of demonstration for features that Matplotlib provides, and also for scientific notation. You can say that these are actually scientific sets. Scientific, you can import thinker from Matplotlib, and then a formatter, you say that set scientific, and then you will have scientific notation here, and you can limit the power as well. And also label spacing. Some cases you need really spacing when you want to, especially for output, for making the output, for generating a figure out of these graphs. Sometimes, they become a bit distorted, and then you need to really use this kind of padding or margin to align them. And this is actually sometimes you need to go to these RC programs again. And also for axis adjustment, and this is mostly the same. And for the grids, if you want to display the grids, that's pretty simple. You can enable grid on axis objects. And for spines, it means that you can control on the lines. You can see here you say that for spine at bottom, set the color blue. So this is actually the boundary of the graphics. At the same time, the axis as well. And for twin axis or double axis, it means that you want to plot same graphs, two let's say curves in one graph, but they have different scales. They have different data ranges. In this case, you can see one is the blue one is from 0 to 205, and the red one is from 0 to 140. And in this case, you can use this twin axis, and this is quite easy to enable in Matplotlib, because as I said, it is a sort of object-oriented APIs, and you can create different objects and then plot them on the same plot, and then it plots because you just change the alignment of the axis, and then you use the same technique to plot two curves in one graph. And then you can see that you can align the position of the axis. And there are lots of styles that you can use in in Matplotlib, like scatter graphs, bar graphs, and also polar ones, histograms, lots of stuff. And there is a link here to Matplotlib gallery. You can check it out and see that, yeah, this is actually quite nice. And there are all code examples are also available. So if you click on any of them, these are like demos. So you can see the code that has generated the graphic, and you will find something that is close enough to the graphic that you want to generate for your publications or for works, for your presentations or whatsoever in this gallery. So these are actually the different types of objects, different plots that you can create. As I said, histograms, and also for text annotation in the LaTeX format on the graphs. This is quite easy to be done. And with subplots, this is something that we discussed, but this is custom subplot, and this actually allows you to span or stretch sometimes these subplots into multiple columns or multiple rows, and that's quite easy for some special graphs. For example, especially for panels, for dashboards in real-time data plotting, this becomes very handy. And then, yeah, this is something that we discussed in the beginning. And color map and color figures, contour figures, sorry, you saw that in the gallery. There are so many different things, and this is indeed sort of plotting contours. So as we discussed in the NumPy video, this is where this mesh grid comes very, very handy. So you can say that a mesh grid of 2 x and y, so you have a grid, and then you can compute this third quantity, the third variable, in this case z, based on that. So this is actually how it works. And then you can plot easily these kind of contours, field contours, or just the bounds, or plot them in 3D figures. So you can see that this is actually the same thing. This is the contour, and this is the 3D representation. And you can also plot just the frames, or super nice. You can see that it shows that this is the same figure. If you just watch, if you just see it, observe it from the top, and plot the highest points with red and the lower points with blue, you will see something like this. That's the correlation between 3D and 2D graphics. And yeah, this is a very nice figure that you can plot the projections, and this is, you can see that it's quite easy because it's not a projection, it's just plotting things. You can see that this against x against y, or z against x, or something like this, in different positions. So just moving the axis. This is the beauty of the object-oriented API that Matplotlib provides. And then yeah, and then yes, here the changing the angle, changing the cameras. You can look at this as that. But also animations. This is also quite easy to create, and in MATLAB it's also easy to create animations. But yeah, here provides a frame by frame sort of capturing of shots, and then interpolating it into an animation. This is what Matplotlib does. And yeah, this is the example that you saw in the video of SciPy, the pendulum example, and this is just plotting the solution in in an animated way using Matplotlib. Okay, cool. So this is actually what I wanted to show you from Matplotlib. Make sure to check it out. I mean, this notebook. Make sure to check it out, and I'm sure that you will enjoy it. You just clone the repository and then run these examples, try to modify them, and then you will see the power of this nice library. I hope you enjoyed this video, and yeah, see you in next videos. Bye.